All right, guys, today's lesson, lesson 31, is solving rate and ratio problems. It's not that difficult. I want to get you kind of into a lot of this is going to be review. No more conversation here. All right, a lot of this is going to be very reviewish for you, but I'm going to stretch you on a couple things that we're going to be doing. So solving rate and ratio problems. We need some definitions, don't we? What are the definitions we need right out of the blocks here? Rate and ratios, right? We need ratios. And you probably already know, you know what rates are, right? We've talked about this before. What is a rate? What is a rate? It's a comparison of two different units, like miles per hour, right? 63 miles per hour, $3.92 per gallon, all right? Those are rates, all right? A ratio is
the percent of possible. No, that's a probability. Sorry.
a ratio. Probability is a ratio. A ratio, yes.
It's like the comparison of two numbers.
It's the comparison of two numbers by division. That's exactly right. So a ratio is a comparison of two numbers by division. Okay. A rate is the ratio that compares quantities measured in different units. Right. That's the two that we just defined. And then a third definition that we're going to make use of, a unit rate is a rate whose denominator is 1. Okay. A unit rate or unit price is a cost per unit. For example, 55 miles per 1 hour. That's a unit rate because the denominator is 1. $2.50 per box. That's a unit rate, right? If a dozen donuts was $12, what's the unit rate? $1 per donut. Okay, the unit, one donut. What does one unit or one item cost? Of course, you could say that the one box is, per box is also a unit rate. But the unit rate is a rate whose denominator is 1, and we'll use unit rates when we do comparison of rates. If we're trying to compare rates, 600 miles per 10 hours. Compared to 130 miles per 2 hours. Which one is faster? 600 miles per 10 hours or 130 miles per 2 hours? 130 miles per 2 hours is 65 miles per 1 hour, and the other one is 60 miles per 1 hour. Okay, so we can make unit comparisons. It's easy to make comparisons if we're in a unit rate. Okay, so I didn't write that down, but we're talking about 600 miles per 10 hours or 130 miles per 2 hours. You got to be careful. You might want to jump on this one just because the 600 is bigger, right? But we want a unit rate, so we simplify those. This would be 60 miles per 1 hour, and this would be 65 miles per 1 hour. So the second unit rate or the second rate is greater. Okay, it's easier to make comparisons when we're talking about unit rates. All right, for example, which is the better buy? 5 cans of tuna for $4.95 or 6 cans for $5.75? Don't guess. I want to know some answers here, right? So 5 cans for $4.95 or 6 cans for $5.75. So we want to know the price per can, right? So we want to know what $4.95 per 6 cans comes out to be per 1 can, right? So we're going to do that. We need to just divide $4.95 by 6. 5. Yes, thank you. I'm a little flighty today. What do you get there? 99 cents, right? 0.99 dollars per 1 can. That's the unit rate. And the other one is $5.75. $5.75 for, wow. $5.75 for 6 cans. I'm always real tired on Thursdays. Wednesday night church kind of. What is this?
It's 93 cents. You're right. It's 93 cents. It's 93 cents.
I got 95 and 5/6.
All right, y'all listen. Y'all listen. We don't really need all this conversation. All right, 6 cans into 5.75. You guys have got to be better than this. 6 goes into 57. 9 times, that's 54. Right? That's 3. Bring down the 5. That's 7 times. Right? And that's 9 times 7. 5. Man. All right. All right. Y'all listen. Y'all listen. All right. 5 times, that gives us 30. Subtract there, that gives us 5. Bring down the 0. Why do I need to do that? Yeah, because we have to round. Now, but at this point, we could answer the question, couldn't we? It's going to be 95 or 96 cents per can, and the 6 can price is cheaper, right? And I'm not sure who said that or what at the outset, but we have to do the calculations to see. It'd be really tough to do those 2 calculations in your head. We had a hard time doing it on paper. All right, so make sure that you are giving good reason. All right, it's not a rush, it's not a race. A chemist raised the temperature of a liquid 45 degrees in 1 minute. What is the amount in degrees Fahrenheit per second? Okay. So the chemist raised this thing 45 degrees Fahrenheit in 1 minute. Yes. So we need to change this to seconds. How do we do that? We need to change minutes to seconds. Right? 1 minute is 60 seconds. Toddy, you got a question?
No. Well, what if I just took the numbers and divided 45 by 60?
All right, so if you do that, it's going to give you the correct answer, but you're going to have teachers upstream from me, and so I'm going to do it now. You got to show the unit multiplier.
Okay.
You have to show the unit multiplier in your work. And you've already had that in physical science, right? Your physical science, they make you show the unit multiplier to do your conversions. It's going to save you a lot. Y'all weren't in chapel yesterday. Well, some of you were. We did some unit conversions in chapel yesterday. Somebody tried to correct me on one, but he had his unit multipliers reversed. Yeah.
Well, I live with the kid.
I love the kid. He's my favorite, one of my favorite all-time kids. All right, so we'll cancel the minutes, which is what we want to happen, and what we're left with is 45 over 60, right? This is degrees Fahrenheit over seconds, but I want the amount in degrees per how many seconds?
Per
1 second. So the only way to express this as a unit rate is 45 divided by 60, which is 3/4, right? So it's 0.75 degrees Fahrenheit per second.
You just write out per second?
Yes, you can. Yes. All right. Now, that's the rate of change per second. So what this problem is asking us for is to convert this unit rate to another unit rate. It would not be correct to put this as the answer. Even though that's a good answer, that's not the answer that this problem is asking us for. They're asking us per 1 second. That's a unit rate that they're asking for. Yes, Liam? Yes. All right. Now, let's move on. Question number 3. An engineer opens a valve that drains 60 gallons of water per minute from a tank. Now listen, how many quarts were drained per second? All right, so I want you to work on this. Go ahead, work quietly on this. 60 gallons of water per minute. How many quarts were drained per second? Now, if you sit and think your way for just a second here, you really save yourself some time.
Yes.
Whoa! Whoa!
Make sure you say no more talking, guys.
All right, so let's have a look at this. What's the answer, by the way?
1,440.
4 quarts.
4 quarts per second. And it's really pretty simple if you think about this, right? 60 gallons of water, 60 gallons per 1 minute is 60 seconds. That's 1 gallon per second, which is 4 quarts per second. Now, if you wanted to be meticulous about this, which a lot of your teachers would require this, and 60 gallons per 1 minute, our unit multipliers would be 1 minute is 60 seconds, and we've got to convert gallons to quarts. 1 gallon is 4 quarts, right? That's how your unit multipliers would need to look, right? So gallons cancel, and minutes cancel, and what are we left with? Quarts per second. The 60s cancel, and we're left with 4 quarts per 1 second. Okay? All right, so using the unit multiplier really doesn't take a whole lot more time. It really doesn't take us a lot more time to do it that way. Okay? You get there, right? So what did you do wrong, Cooper?
I multiplied 60 times 60.
Okay? So, but why is this funny? All right. If you don't do your unit multiples correctly, then we got issues, right? And as soon as you flip things around, let me kind of go backwards here a little bit. And what you did is you did this. Now, if you're using your units, Cooper, if you're using your units, if you put 60 seconds is 1 minute, and if you multiply this together, what do you get? Minutes times minutes is minutes squared, gallon seconds. We get into some really strange units. If you have your units visible, then you'll know you've done something incorrect. Did you have your units visible there? Yeah, a little bit. So just kind of make sure that your units that you want to go away are canceling, and the units that you want to stay are staying. All right? Next example, or next little part of our lesson. A proportion, and this is review. A proportion is an equation that shows two ratios are equal. This equation, 3 over 5 equals 9 over 15, is a proportion. All right, how do we know it's a proportion? It's two ratios. What are ratios? Ratios is just a fancy way of saying it's a fraction, right? Two fractions are equal to each other. So 3/5 equals 9/15 is a proportion. Now, one of the most important things that we use, and we use this all the time in mathematics, is the cross products property. The cross products property says if you have a proportion, then the product of the means is equal to the product of the extremes. All right, now that doesn't mean a whole lot to you at this point. It's also going to work very well in your favor. Geometry, you're going to use this all the time. Geometry uses proportions. Okay, you're going to set up the proportions of similar figures. We're going to do it today. Okay, So the cross products means that you can multiply, cross multiply, only if you're dealing with a proportion. We don't cross multiply when we're dividing fractions. We don't cross multiply when we're multiplying fractions. We can cross cancel when we're multiplying fractions. But cross multiplying only happens when you're dealing with proportions. Okay? Proportions are used to represent many real world situations that require finding a missing value. So we have to find a missing value, and we'll use similar ratios, similarity of things to do that. And using cross products is an efficient method for solving proportions. It's the most efficient method. So here's an example. Solve this proportion using cross products. Not using your powers of observation, not doing it in your mind. Use the cross products to solve. So if we're using cross products to solve, what would the next step in this equation look like?
15x.
15, 3x equals
15, 2.
30.
15 times 2, 30.
And so x equals 10. Now you could logically do that, right? 3 times 5 is 15, so 2 times 5 has to be 10. But I don't think that's a whole lot quicker than just doing the cross products and trusting the process, right? So the process is what's important here. If you can do the process, then you can work with more difficult problems like this. Okay? X minus 1 over 12 equals 1 over 6. Incidentally, we'll have a quiz pretty early next week on solving proportions. Just problems, little equations like this. Extremely important skill. All right? And one thing you have to remember when you're solving ratios, or proportions rather, is that a fraction bar is a type of grouping symbol, right? So this fraction bar right here groups this as one thing, x minus 1 in parentheses, right? So when we cross multiply, what do we have to do to the 6, with the 6? You have to distribute the 6, right? So 6 times x minus 1 will be 6x minus 6 equals 12 times 1, which is 12. Now we can add 6, divide by 6, and we get x equals 3. Now, could you have seen that at the beginning of the problem? Yeah, you probably could. What does this numerator need to be? What does this numerator? It needs to be 2, right? Because 6 times 2 is 12, so 1 times 2 needs to be 2. In order for this to be 2, x has to be 3. Okay? So you can reason your way through it, but we're going to get into some equations where you can't. So the process is extremely important. All right? We're getting close. Y'all hang with me. This is a difficult one. The ratio of boys to girls in a math class is 3 to 2. That's about what we've got here. The class has 25 students in all. How many boys and how many girls are in the class? Now, can you logically figure this out? What would you think? How would you do it, Bo? Just using just kind of common sense.
I probably should divide by like one of the numbers and then just I can't really explain it.
So what do you think the answer is?
15 boys to 10 girls.
15 boys to 10 girls is correct, right? Toddy?
You were at 5, because 3 and 2 is the total amount, and divide 25 by 5.
Yeah, so if we're saying it's a ratio of 3 to 2, that means there's 5 partitions, right? 25 divided by 5 is 5. So we've got 3 groups of 5 that are boys, that's 15. 2 groups of 5 that are girls, that's 20. But what if we were talking about a proportion of chemicals in a mixture? And it's 3 to 2, and there's 17.1 liters. Then we can't, it's not set up for us to do that, is it? Okay, so that's going to require a little bit more computation. So here's kind of how I want you to do this. Y'all, this is going to be confusing, but it's going to pay dividends for you later. You're able to figure it out logically, and that's great. But anytime you're dealing with a mixture of two things, you let x equal one of the things. So let's let x equal boys. You're going to need to write this, I promise. If X is boys, what is girls?
Y.
No, let's don't use Y. That's two variables. We can't really solve equations that have two variables, can we?
Girls equals
If all right, let's say there was 7 boys, how many girls would there be?
7 boys.
18.
Which is 25 minus 7, right? If there's 10 boys, how many girls would there be? 25 minus 10. Okay, if there's 12 boys, then there would be how many girls? 25 minus 12, right? So if there's X boys, how many girls are there?
25 minus.
25 minus X. Okay, if we had a 17-liter solution, there was X of one thing, there's 17 minus X of the other thing. And that's a pattern that you need to learn to get used to. X, the total minus X. That's the two parts. Doesn't that make sense now? Okay. What do we know about this ratio of boys to girls? X, boys to girls, equals 3 to 2. Right? Are y'all tracking with me here? Cross multiply, we get 2x equals. Cross multiply here, remember you got to distribute. 75 minus 3x. Now we're seeing a lot of these unit 3 tests we just took, these simple equations coming into play. We need to be very efficient with these, right? Add 3x to both sides, we get 5x equals 75. Divide both sides by 5, we get x equals 15. So there's 15 boys. 25 minus 15 is 10 girls. Okay? Now, this ratio is always going to work. So if you're talking about a partition of two things, let one be x, and the other one is the total minus x. All right? Does that make sense? I know that's a little bit more complicated than we have to be with this problem, but the process that I just gave you will help you do any mixture problem that you're looking at like this. Okay? All right, we're almost done. On a map, Albany to Jamestown measures 12.6 centimeters. Jamestown to Springfield measures 9 centimeters. Springfield to Albany measures 4.75 centimeters. What is the actual distance from Albany to Jamestown to Springfield and back to Albany? So what are they asking for? They're asking for the perimeter, but they're asking for the distance in kilometers, right? All right, so how would we do this? We're given a really nice, important piece of information right down here at the bottom.
1 centimeter
The
equals.
scale is 1 centimeter to 25 kilometers. Okay? All right, so we would need to do, add all three of these things together. What's 12.6? We're going to do this mentally. Plus 9, that's 21.6. 21.6 plus 4.75 is 26.35. Is that right? So 26.35 is X kilometers.
You forgot to do 3. 5.
Thank you. 26.35 is X kilometers. And the ratio here is 1 to 25. Cross multiply 25 times 26.35. And that's kind of something that we might want to use a calculator to do. 25 times 26.35 is going to give us our total distance in kilometers. All right? Using ratios and similarities. Now, you could probably have figured out, we've got to multiply by 25. But I want you to learn to use proportions and similarities or scales to figure out your solutions. Okay? All right, we're going to skip that one because it's pretty easy. Page 193, A through H, 1 through 15, 17 through 29, odd. We don't have enough time to get started on this, so just write this down and and get rolling. I think, does anybody have the syllabus? I'm pretty sure this agrees with the syllabus.
Is this today the 19th?
Today is the 19th.